Hey guys, Craig and Nick from the Build a Beamer project again. We've just finished the rebuild on our motor and it's going to be going back in the car today. But Nick felt that we should probably do a bit of a reshoot of the M50 manifold conversion because we've had a lot of questions and a lot of views on our original video. And a lot of the stuff that we wanted to explain are things where people have asked about stuff that's going on underneath the intake manifold. So right now we've got an opportunity to show that in a little bit more detail, and so we decided we're going to run through the entire process once again. So I just want to start off with the why. What's the reason that we go for this M50 intake manifold compared with the original M54 manifold? And it's really got to do with the size of the intake runners. The runners are substantially bigger than on the M54 manifold, and you can appreciate that when you have a look at the size. When you measure up on the M54 B30 manifold, we're apparently about 40 something percent bigger surface area here, and you can see as well the intake manifold is a very simple design, just straight in, turns to about 90 degrees, and then into the intake plenum, and off you go. So that's really the reason. The whole idea is just enabling the car to flow more air. By comparison, the M54 manifold is designed to optimize the car over a far broader operating range. And so under low RPM conditions, you do lose torque if you've got very big intake runners. Because the flow velocity of the air is quite low. And so what BMW did when they designed their multiple length intake manifolds, in the case of the M54 B30, it is a dual length intake manifold where the diesel valve changes the length, and what it does is it forces the air to follow a longer path, getting into the intake at low RPM, and what that does is it accelerates the air, you get higher velocity, and through that you get better cylinder filling. We don't need that. We're operating this engine under race conditions, generally between 4.5 and 7,000 RPM. And so we really want to dispense with any optimization that happens down in the low RPM range. We want to dispense with any trickery that BMW has come up with to optimize fuel efficiency and low RPM drivability, and all we want to know is how do we get the most power out of this engine in that high RPM range. So that really is the reason behind this. This is a modification which is extremely commonplace and extensively applied in North America, and I think in Europe as well. But it is worth noting that we've had a lot of criticism of this mod in South Africa, and to be honest, we haven't found a single person who believes that this modification actually helps at all. Now, that may be true because of something that we've overlooked, and one peculiarity up here, of course, is that we're at very high altitude. So we're at about 1,600 meters above sea level, and it may be that this modification becomes less effective at these altitudes. But certainly the guys that we've spoken to that do run them or have attempted these under race conditions have claimed that the modification doesn't work. That said, we're very happy with the performance of this engine with the M50 on it. We don't see any great big holes in the torque curve. In fact, if anything, we've got an extremely flat and predictable torque curve, and we're getting decent power at the top end. So we're quite happy with where we are with the mod so far. So moving on, the most important thing and probably the trickiest thing once you've sourced your intake manifold is dealing with your throttle body and the intake boot. So let's have a look at that over on the manifold itself. So if you don't want to go to the trouble of converting your M54 B30 into a cable throttle driven engine, then you want to retain your electric drive-by-wire throttle body, and the problem with that is that does not bolt straight up onto the intake manifold. So you do need to have an adapter made up, and because the holes are almost in the same place, the only way to have that work is actually to rotate the throttle body, in this case probably about 15 degrees clockwise, so that you can bolt on your custom-made flange onto the throttle body, and then you bolt your throttle body onto the flange itself. We had this made up by a friend of ours who has a precision machine shop. If not, you can either do your own thing, but you can also source these directly from a company called Seems Legit Garage. You'll find them on the web, and they sell a modification kit. So check them out. It seems legit garage. Then, as far as the intake boot is concerned, there are two types which you get, and there's a type with a single vacuum port on the bottom, and then there's this type here which is the double vacuum port. I can't recall which is which. I believe this is actually off the S50 motor, and the reason we originally sourced the one with the double ports is because we were going to use the secondary port for drawing vacuum for our oil cash can. We've subsequently changed that design, so this is simply blocked at the moment. I've got an HDPE irrigation fitting plugged into the second one, and a hose clamp, just keeping that under control. Alright, so fuel rail and injectors. So the one problem that we have with the M54 intake manifold is that the injectors actually are introduced at a very steep angle. It's got to do with how complex the actual runners are in that, and as a result the injectors come in at a very sharp angle to the intake itself. Now, because of that, these are special injectors. They're actually designed not with a direct flow pattern. The flow pattern is actually off at an angle, so that despite the fact that the injectors come in at a very steep angle, they try and inject basically straight into the airflow. So if you do reuse your original injectors, you're basically going to be injecting past the airflow, and it works. It seems to run absolutely fine, but we decided to replace it with injectors which would go directly into the airflow. These injectors happen to be sourced from, I think it was some Ford application. There's a lot of information on the web in terms of what you can use there, but the Bosch equivalent part number is over here, 0280 155 715. 0280 155 715, and we'll try and leave that part number in the description. If you do want to boost your motor, or you are going to be getting a lot more horsepower out of them, then certainly you'll be wanting to go with slightly bigger injectors. These are not. These are fractionally bigger, I think 5-10% bigger than the originals. We were looking literally to find something which matched. Just remember as well that your fuel rail, you will be retaining your original M54 fuel rail, because the M54 is a one-directional fuel rail. It does not have a return. So you do retain this fuel rail, but now it sits in a completely different position. Fortunately, we do have two threaded points on the new M50 intake manifold, which you can then use to secure and hold your rail down. And in this case, we've just made up a couple of very simple brackets which hold it down. You can use aluminium flat bar or anything else you like. There are also a couple of ears which you will need to grind or cut off on the fuel rail holder itself, but that's all very self-explanatory when you do the mod. Okay, now getting on to the underside, which is the bit where people have often got a lot of questions, and the first part goes to the idle air control valve and how to deal with that. So basically what we're doing is it was very little new hardware required. We managed to reuse pretty much everything. So the first thing is your original idle air control valve has got a bracket attached to it. It's got some unnecessary paraphernalia. We just ground off the extra bits, and when again just needed to extend that to get it into the right position to hold the idle air control valve in such a way that the inlet is right at this port on the underside of the intake manifold. Now, if you'll bear with me a moment, I just scampered off to the other side of the garage to show you that on the M54 intake, your idle air control valve fits into this little device, and basically it just ensures that the flow turns through 90 degrees. You can use that same grommet, I guess it is, but in this case you don't need the 90-degree elbow, so you simply cut that off on the end of the barbed edge, and this fits perfectly into that port, and you just jam your idle air control valve in there, and it fits very nicely. From there, it's simply a task of routing a pipe around from the intake side of the idle air control valve into the boot. In this case, we reused one of the existing hoses that we had, complete with what looked like very custom bends on them. They're just there by accident. But getting the kind of 180-degree turnaround proved to be a little bit more tricky, and so we ended up putting in a little elbow over here just to help transition. So it's anything but elegant, but it certainly does the trick, and idle side of things works absolutely perfectly. Then the next thing you need to be aware of is the intake air temperature sensor. The M50 manifold does come with its own air temperature sensor, which is a threaded sensor, and it threads into this port on the underside of the intake manifold. However, that sensor is not compatible with the M54 DME. So what you need to do in your case is you take your M54 temperature sensor, which is a clip-in sensor, and just with a bit of butchering on a grinding wheel, grind it down to more or less the size that you need to get to, and then run it through a die. And I think it's an M12. Yeah, if I'm not mistaken, I think it's an M12, but you'll check it out once you get your own. Run it through a die, and then you can simply thread your original M54 intake sensor into the M50 manifold. And then finally, the last port on the underside here is this very small little nipple, and this is perfectly convenient to attach your fuel pressure regulator pipe, which is just a thin hose which runs up from the fuel pressure regulator on the underside of the car into the engine compartment, and you're going to plug that in the back there. All the other bits and pieces of complexity that were originally jammed in underneath this motor, the charcoal canister, I think there's a recirc solenoid valve, there's all manner of stuff, sucking jet pumps, all of that stuff just gets chucked out, and it becomes very simple. All that you have going onto this manifold is your fuel pressure regulator, your fuel, and your vacuum for the brake booster, and I'll show you where that goes in a moment. So once we flip it over, we're left with that last port over here, and this is where we attach our brake booster. That does again require a little bit of fettling and making a plan with some hoses, but once you've done that, your brake booster gets its vacuum off there, and that works absolutely perfectly. So what you'll see is, that is so less complex and so much simpler than what we previously had. We've got no more DISA valve. We've ditched that entire PCB system, which quite frankly is just an absolute source for disaster. They leak, they crack, they clutter everything up. On a race car, we don't need that stuff. We're running into a catch can, and we'll show you that connection in a moment. So it just simplifies everything. We've got rid of all of those things that I've just mentioned a couple of moments ago, the sucking jet pump being one of them, which is what allows you to basically get manifold vacuum onto your booster, but also to run into your charcoal canister, I think it was, or one of those things. But most importantly, what you'll see is getting this on and off now becomes, exceptionally easy, and trackside repairs and so on will really thank you for this. So once your intake is on and you spun your nuts on, and you really can't get it simpler than that. But getting in and underneath the intake to grab something or change something or check something is all of a sudden possible. With the M54 manifold, it's not. You've got to get that off, which is an active contortion in itself, and then a huge amount more work. So it really is, from a race perspective, it makes a whole bunch of sense for us. It simplifies things tremendously, and just make sure that we still have access with our hands to all of this placed down here. And so while I'm at it, let me just quickly talk about the other mod on this engine, which is the S50 oil filter housing. The reason we went for the S50 oil filter housing is that it does have the external oil cooler ports on it. But in doing that, we've now got a situation in which we are short of a port for oil pressure and oil temperature sensors, because this only has 2 ports, whereas the the M54 has one for the Vanos plus one for the oil pressure plus one for the oil temperature. And then in addition to that, we wanted our own external oil temperature gauge. So you can buy these little adapters off eBay or any one of the online stores. We call this a Christmas tree, and basically by using one port only, it allows us to multiply the number of ports that we've actually got. There is a fourth one at the back here, which I suppose if we oriented things slightly differently we could use as well, but we're fine. We've got our DME oil temperature and oil pressure sensors in here, and we've also got our standalone gauge oil temperature sensor on there. So that works really well, and then from here we go out to our external oil cooler. We did have to re-tap the Vanos line. That is not tapped to M12 standard, so that's a tapping job, but other than that, relatively straightforward. Good. So hopefully that's. Nick's just pointed out one more change here. So of course, when we get rid of the PCV system, the drain down into the dipstick, into the crank, into the sump now becomes redundant. This is quite interesting in that this dipstick is different to the M50 and M52 models in that it has this separate section over here. So this is normally the drain down from the cyclonic little accumulator that you have on the PCV system. So we just put a bit of rubber hose on there and a plug. But that is quite interesting in that we believe that, we presume anyway, that is actually a suitable return point for a turbo application. We've not managed to find anything that contradicts that yet, so we assume that will be quite elegant and a lot easier than drilling and tapping into the sump to have an oil return line for a turbo application. So if there's anybody who's got an opinion on that, by the way, let us know. But yeah, that's probably where we would look to return our turbo oil feed once we get around to boosting this motor. Right. Oh yeah. One of the things that you do have to do, by the way, when you do this conversion, is you'll find there's a whole bunch of holes on the head. These are secondary air intake, and I think they do something like balance the air pressures or something between the ports. I'm not entirely sure of what they do, but you have to plug them, which is quite simple. You literally just run a tap in there and put in a little stainless steel grub screw. That sorts that out. But obviously, the shape of the ports on the S50 manifold on the M50 manifold are completely different to the M54, which are smaller, much narrower, and D-shaped, whereas those are a perfect oval. You can port your head to match that, or port match it to try and match that. Apparently, it doesn't make a huge amount of difference from a power point of view. We did it. It was quite tricky in the car. The question, I guess, is would we recommend doing it? And my honest answer is probably not, because you can see how very close one gets to the wall here, bearing in mind that we still have to have our gasket, our rubber seal on these sealing in that space. So it's very easy in my view to get a little bit carried away and to grind away a space or at a place where the gasket actually needs to sit, and then have a manifold vacuum leak, and that would be pretty bloody disastrous, because I'm not quite sure how one would deal with that. We don't have any of those, luckily, but as I say, I'm not convinced that it's worth the risk. If you have a look in this area over here, you can see how absolutely precariously close we have come to the edge of the or to the water jacket there. So there's really not a lot of space for the seals. Good. All right, guys. Yeah, I hope you enjoyed that video. I hope it answers some of those questions which do arise from time to time around that M50 intake manifold conversion. And if there's any questions or anything we've missed, please feel free to comment and let us know what you think. Great, thanks.